This is a story about how I learned to enjoy writing tests and the strategy I use to maintain about 90% test coverage during tight deadlines and onboarding brand new developers into the project. I'm a full stack developer technically, but by time spent working on the stack, I'm pretty much a front end developer. So my first excuse for not writing tests was that the UI changes so frequently, I'd be spending more time fixing broken tests than writing new features or fixing bugs. Now, I just said fixing bugs. Remember that for later. Next excuse. When I used to work for a consultancy company / dev shop, we never included writing tests in our quotes to clients because we always assumed that clients didn't want to pay for tests and they didn't want to spend the extra time to write the tests because we charged by the hour. And I like that a lot because that meant I didn't have to write tests. Next excuse. I used to say I'm not writing code that's launching astronauts into space or anything dangerous like that, like airplane software that needs to land airplanes filled with newborn babies. So why do I need to write any tests? Enough excuses. The best developers I know these days demand writing tests, even when the product managers, the product owners, the managers in general would totally let it slide because they're trying to make deadlines and write new features. Even though upper management would let tests slide, these developers demand that we still write tests. They demand high code coverage. They demand integration tests. We'll get to all that later. But the point is, the best developers I know demand tests. These developers treat software development as a true craftsman, a skill to learn, a skill to get better at, and to deliver a high quality product. And I want to be like these developers. They're amazing. I want to be like that. So how do I learn how to love writing tests? Well, I don't know, but I have a couple tips that I've learned along the way that I'm going to share with you. But maybe it's good enough that we know that the best software developers out there are demanding tests and writing tests for their code. And we want to be like them. We want to up our game. So let's explore this together. This is why the best software developers write tests. Avoid annoying and inconvenient customer service calls that always seem to happen at night, a weekend, while you're taking a poop, or any time you'd rather not get them. Good software developers write tests because they plan for the future. I'll tell you what that means. They know that one day they're going to get that call on a weekend on their child's birthday, and it's going to be that customer service call that says, hey, something's broken on the website. Why doesn't your code work? Good software developers don't want that call. So what do? They write tests. Here's the thing, though, that I find actually very interesting. Good software developers and bad software developers, and when I say bad software developers, I'm talking about people who don't write tests or who don't like writing tests or who think writing tests are pointless. Good and bad software developers both don't want that phone call. But the good software developers are actually anticipating that their code is always not going to work, and they're writing tests to prevent those calls. I don't think you could prevent 100% of those calls, but you could prevent a lot of them from happening by testing your code. So good and bad software developers don't want that call, but the good software developers are actually doing something about it to not get that call. The second reason software developers write tests is because they want to find problems before their customers find problems. You don't want to rely on your customers telling you about your bugs because that's just bad customer service. And they might not even tell you about your bugs. They may just stop using your software. The third reason for writing tests is to stop whacking moles. Tests help solve the infamous whack-a-mole problem. That's when you fix a bug over here and then another bug pops up over here, and then you fix this bug over here and then another bug pops up over here. This is exponentially more frustrating than writing tests. And there's one more part to this too. It's when you fix a bug and then you think it's fixed and then all of a sudden it reappears. That is very, very frustrating. And you don't want to spend your weekends dealing with that. So just, fix your bug, write the tests that ensures that it stays fixed, and you're probably good to go. And I can assure you that it's exponentially more frustrating because I know from firsthand experience. I think it happens to all of us. And we eventually just get beaten down and just write tests. So learn from the mistakes of others and just do it now. This channel is about having the craftsman attitude to software development. So we're going to avoid the late night calls. We're going to avoid the weekend calls, the weekend bug fixes, and we're going to test our code. Now the question is, how do we do it? This isn't going to be a step-by-step tutorial on how to set up tests for your software project, because if I did that, this video would be obsolete in about 5 seconds. Instead, I'm going to give you the recipe and the principles behind maintaining high code coverage for your project, even through tight deadlines and onboarding new developers. And if you're wondering why you should listen to me, well, the truth is you don't have to. This is just my little hobby video project. But I can assure you that these are hard-won lessons that I've learned launching a highly anticipated product at one of these FANG-type companies. Step 1, unit tests. Set up a unit test framework for your project. Unit tests test a specific unit of your code, like a function, for example. And if you're nice, you could write the first test so that everyone else after you knows what's going on and knows how to write tests for that framework. So set a standard, a high standard. For example, when you're setting up the test framework, require that 90% of all new code or maybe existing code is covered by unit tests. And make sure code cannot be committed even on the developer's own machine, without passing this test, if possible. There are different ways of enforcing this rule. Here's a few. Before a developer commits their code, run the test suite. If the code coverage isn't sufficient or a test fails, don't allow the commit to be committed. You could use something called pre-commit hooks in Git to do something like this. So after the developer commits their code and pushes their changes up to a feature branch, and then they want to request a merge to merge it into the main branch, you want to run the tests again. You could use a CI, a continuous integration. A CI is what we call it in the industry. And you could run the tests automatically when the request is made to merge in the code. And again, if the code coverage isn't sufficient or a test fails, everyone who is approving the request to merge can see that. And maybe you can't even allow a merge to happen in that place unless you do this, override or something like that. So here's an example of a GitHub pull request that I was creating for a project. This is for Amplify CLI. If we go to the checks tab, we could see the checks that ran when I created the pull request. You could see that there's this looks good to me analysis for Python and JavaScript. And if we open the Circle CI accordion, and then we go to build, test, deploy, we could see that a lot of different tests were run, build, mock, and the unit tests. And you could see the status, whether they succeeded or they failed. That's an example of like a CI/CD system running your tests for you automatically. Step 2, integration tests. Set up an integration test framework. Integration tests are different than unit tests because they actually test your software as a customer would use it. For example, you could test in the entire logging in function of your software. So when a user logs in and authenticates, and then you could test a user updating their profile. So instead of testing like a specific unit, you're now testing an entire workflow end to end. That's why it's called integration tests or end-to-end tests. Integration tests can be written very similarly to unit tests, but sometimes you may need different tools, especially if you're testing user interfaces. Because when you're testing user interfaces, you may need to mock how the user interacts with the interface. So you may need to mock a keyboard input or a mouse. So code coverage doesn't really work with the concept of integration tests. So instead, you want to pick out the important features that your app does and test those. And you could break them down into smaller pieces to make it easier to test. So when you run an integration test, you want to make sure that they all pass. That's pretty much it, because there is no code coverage. So if your website or your app creates blog posts, you want to make sure that you want to write a test that creates a blog post, and then you'll confirm that the blog post has actually been created. So if you're like me and you're setting up these new requirements for code coverage and testing, then you may feel a little bit like an a-hole doing it and forcing people to comply.
You have 20 seconds to comply.
Especially if writing tests is new for your team. So I'm going to say a few words that will hopefully alleviate that a-hole feeling. So when someone did this to me and now I was forced to write tests, I was mad at first, of course, but that went away. And I actually appreciate now that I was forced to write tests. I feel like personally I've learned a lot of new skills doing that. And this is going to be something that I take forward into every project I do in the future. And writing these tests have actually caught a lot of bugs and issues before the code ever got sent out into production, sent out into the wild for customers to use. And so that saved us a lot of headaches. And so I appreciate the time saved and the frustration saved. So you're pretty much doing this for your future self, your future teammates. And it's a great feeling. You're treating your code as craft and you're taking it seriously and you want to deliver quality products. If you want to treat software development as craftsmanship, I think testing is definitely the way to go.